today we're going to learn about how to find the greatest common factor, or GCF, for pairs of numbers. So factor, if you'll remember, means two numbers that you multiply to get another number, and the word common means something you share. So we're looking for the greatest or largest factor that these two numbers share. So we have 4 and 20. So we're going to write out a factor list. So we'll write the number 4 and the number 20. And let's see, what two numbers can we multiply to get 4? Well, obviously there's 1 and 4. And notice I'm writing them kind of far apart. I don't need to write a long list, but I'm going to be creating a list of numbers here. And I'm going to put my smallest number and largest number at each end. So 1 times 4. And I know that 2 times 2 equals 4. Well, there's no numbers in between 2, so once I know that 2 is my factor, I'm done. 1, 2, and 4 are factors of 4. So let's look at 20. 1, and I need maybe do a little longer list here. 1 times 20, 1 times 20 equals 20. And it's an even number, so I know 2. 2 times 10 equals 20. 3, no, 3 times 6 is 18, and 3 times 7 is 21, so 3 doesn't work. What about 4? Yes, 4 times 5. And once again, once I have two numbers that I multiply, or two factors that I multiply to get this number, and there's no numbers in between, I know I'm finished. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And I'm looking for the greatest common factor. So here's my list of factors and factors that they have in common. And since I'm looking for the greatest, I'm going to look at the large end of the list. So I know it's not 20. I know it's not 10. I know it's not 5 because there's no 5, 10, or 20 up here. But I see a 4 in both of those. So the greatest common factor of 4 and 20 is 4. Let's take a look with 18 and 63. So 18 and 63. Well, 1 times 18 equals 18, so I can use those. 1 times 18. And it's an even number, so 2 times 9 equals 18. And let's see, 3. I wonder if 3 will go in. Yes, 3 times 6 is 18. What about 4? Well, I know 4 times 4 is 16, and 4 times 5 is 20, so it doesn't sound like 4 will go in. 5 will not go in because the number does not end in 5 or 0. And we're back at 6. So 1, 2, 3, 6, 9, and 18 are all factors of 18. Let's try 63. 1 and 63, because 1 times 63 does equal 63. I won't use 2 because it's not an even number. I think 3 will go in because 3 goes into 6 2 times and into 3 1 time. So let's try 3 times, yes, 3 times 21 equals 63. And let's see, 4 won't do it, neither will 5. Again, it does not end in 0 or 5. And 6. Well, 6 does go into 6 one time, but it only goes into 3 half a time, so that doesn't work. And 7, well, there's 7 times 9, and that equals 63. And, well, let's see, 8 doesn't go into 63. I know it goes into 64, but not into 63. So here's my factors: 1, 3, 7, 9, 21, and 63. And I want to look again for the greatest common factor. Well, there's no 63 in 18, so I'm done with that. There's no 21 up here in the factors of 18. Well, here's 18, but there's no 18 in the factors of 63. But I do have a 9 here. So the greatest common factor of 18 and 63 is 9. I'm going to show you another way where instead of just using the factors, we can use the prime factorization to find the greatest common factor. So let's see, prime numbers, 2 times 2 equals 4, and that's the prime factorization of 4. And with 20, I know that 2 times 10 equals 20. Those are factors of 20, but 10 is not a prime number. And let's see, 2 times 5, those are factors of 10. Now all I have left are prime numbers, 2's and 5's. So I have the prime factorization of 4 is 2 times 2, or 2 squared. And the prime factorization of 20 is 2 squared, or 2 times 2, times 5. So we want to find out what they have in common. So we created a Venn diagram where we have factors of 4 in the yellow oval and factors of 20 in the blue oval. And where blue and yellow mix in the green, we have common factors, factors that both of these numbers share. Well, I have a 2 here and I have a 2 there, so let's put that here as a common factor. They're sharing that. And they also both have another 2, so we'll put that there. And 5 is only a factor of 20. It is not a factor of 2. So now we're going to find the greatest common factor. So we talked about multiplication. Multiplication here, see, 2 times 2 is 4. So let's see, we'll put that in as a the greatest common factor of 4 and 20 is 4. This time we're going to take a step further and we're going to find the least common multiple. What we can do is we can multiply all 3 of the prime factors. So 2 times 2 times 5. 2 times 2 is 4, and 4 times 5 is 20. So let's check that out. And we will check, and yes, we found out that if you multiply the 2 common factors, you get the greatest common factor of 4 and 20, which is 4. And if you multiply all of the prime factors, you will find out that 20 is the least common multiple. So let's move on from here and take a look at our other pair of numbers, which was 18 and 63. So let's take a look at 18 and 63. Once again, this is the prime factorization method, so we are going to find prime factors. 2 times 9 is 18, but 9 is not prime. But if I do 3 times 3, those are both prime, and I'm done. Prime factorization of 18 is 2 times 3 times 3. 63, 3 times 21 is our factors of 63. 21 is not prime, but 3 times 7 is prime. So the prime factorization of 18 is 2 times 3 times 3, and the prime factorization of 63 is 3 times 3 times 7. So what do they have in common? Well, there's only a 2 in 18, so that goes in the factors of 18 Venn diagram. But they share factors of 3. In fact, they share 2 factors of 3. Both of these have 2 3's. But 7 is only a factor of 63. So we will multiply our common factors here. 3 times 3 is 9. So our greatest common factor is 9, just like we found back here. The greatest common factor of 18 and 63 is 9.